Hi everyone. So we already covered some topics in trigonometry, especially trigonometric ratios and some problems related to trigonometric ratios. So we can continue our class. We are going to move to the next section, that is trigonometric identities. I think that name is familiar for you. Not trigonometric identities that we already heard in our lower classes. When an equation is said to be an identity, yes, if the values of variables included in that equation holds for all values, or that equation is satisfying for all values of variables, such type of equation are called identities. So can you say what you mean by trigonometric identity? Yes, if the identity involves trigonometric values, or if it is whole for all trigonometric values of angles, then such type of identities are called the trigonometric identities. So in this section we are going to prove some trigonometric identities. Okay, in the trigonometry we are mainly dealing with which type of triangles? Can you say which type of triangles? Yes, right-angled triangle. So we can start with a right-angled triangle. So here we have a right triangle. Triangle A, B, C. Here we have a right-angled triangle. Right-angle dash angle B. And we have, what is the name of these three sides of right triangle? Base, altitude and hypotenuse. So when you heard about right triangle, what will comes in our mind first? That is the Pythagoras theorem. That is, a triangle is always right triangle if it satisfies Pythagoras theorem. Conversely, we can say if a triangle satisfies Pythagoras theorem, that triangle is always a right triangle. Okay, so what is Pythagoras theorem here? Base square plus altitude square is equal to hypotenuse square. So shall we apply Pythagoras theorem in this triangle? So how it becomes? Base square. Base means here what is the value of base? BC square plus altitude square. What is the value of altitude? AB square is equal to hypotenuse square. So what is the value of hypotenuse? Hypotenuse is AC. So we can write BC square. Base square is BC square plus altitude square. Altitude square is AB square equal to hypotenuse square. Hypotenuse square is AC square. So now we have an equation because this involves an equal sign. So this is an equation. So here we have how many terms? How many terms are involved in this equation? Yes, three terms. When will you say a term? How will you consider it as a term? When it is separated by plus, minus or equal. So here we have three terms. Then we are going to divide all terms by side AC. Okay, first we are going to divide all the sides by the square of AC. So how will it becomes, or how will it the equation becomes? BC square becomes BC square by AC square plus AB square becomes AB square by AC square, and AC square becomes AC square by AC square. So here we have an equation with BC square by AC square plus AB square by AC square equal to AC square by AC square. Then what is A square by B square? Can we rewrite it as A by B the whole square? That we already learned in small classes. A square by B square can be written as A by B the whole square. So can we write BC square by AC square as BC by the AC all square. So we can rearrange it as BC by AC all square. So AB square by AC square becomes AB by AC whole square equals AC square by AC square becomes AC by AC whole square. So have you heard about BC by AC? So we are going to consider angle A. Okay, we are going to consider angle A. According to this angle A, which side is BC? according to this angle A? Yes, this side BC is the side opposite to angle A. And what about AC? AC is the hypotenuse of angle A. So, what is this BC by AC? Opposite side of angle A by hypotenuse of angle A. Are you familiar with that relation? That the relation connecting opposite side of an angle by hypotenuse of an angle? Yes, it's the trigonometric ratio. That is the first trigonometric ratio. Which trigonometric ratio? Sine. Sine of which angle? Angle A. So, we can rewrite BC by AC as sine of angle A. So, we can rewrite it as sine A whole square plus, what is AB with respect to angle A? The side AB, it is adjacent side of angle A. Okay, adjacent side of angle A, and AC is hypotenuse. So that's also another trigonometric ratio. Which trigonometric ratio? Is the trigonometric ratio connecting adjacent side and hypotenuse. Yes, that is cos x. That is cos of angle A. So we can rewrite AB by AC as cos A whole square. Cos A whole square equal to AC by AC. What is number divided by that number itself? It is 1. That is AC by AC can be written as 1. That is 1 square. So what is sin A the whole square? That is, we can write it as sin square A plus next one cos A whole square. That is cos square A equal to 1 square. That is 1. So that is the first trigonometric identity, that is sin square A plus cos square A is equal to 1. What is this? It is trigonometric identity, that is it holds for all angles. If you give a value of A as any angle, that equation is satisfied. You can check it. We are already familiar with some angles. Okay, if we consider angle 45, okay, you can check it. What is sin 45? Sin 45 is, yes, 1 by root 2. And what is cos 45? Cos 45 is also 1 by root 2. Then we are going to check what is sin square 45 plus cos square 45. Okay, then sin square 45 plus cos square 45 equals, sin square 45 means sin 45 the whole square. That is the square of the sin 45. We already know what is sin 45. What is sin 45? 1 by root 2. So we are going to write 1 by root 2 the whole square plus cos square 45. What is cos 45? That's also 1 by root 2. So what will be the square of cos 45? 1 by root 2 whole square. So 1 by root 2 whole square plus 1 by root 2 whole square. That is the square of 1 by root 2. What is square of 1? 1. 1 itself. Then what is square of root 2? That is 2 itself plus again 1 by root 2 the whole square. That is same as 1 by 2. And what is 1 by 2 plus 1 by 2? That is 1 itself. So it's proved. That is, it's whole for angle 45. You can check it by changing the angles. We are already familiar with sin 45, sin 30, sin 60, sin 90, sin. So we can check it using any angles. That is, this trigonometric identities holds for all values of angles. Clear? Clear? Okay, so this is the first trigonometric identity, that is sin square A plus cos square A is equal to 1. Okay, I think you all get it. Okay, then we can move to next trigonometric identity. Next trigonometric identity is also, we can use this triangle. Here also we have the right triangle, triangle ABC. We are again going to write the Pythagoras theorem. What is Pythagoras theorem? Yes, BC square plus AB square equals AC square. Okay, in the first section we divide the whole term by AC square. Next we are going to divide all the terms by BC square. Okay. Okay, so the equation become BC square by BC square, then AB square by BC square, then AC square by BC square. Then we are again going to rewrite this BC square by BC square as, can you guess how will you write BC square by BC square? That we already discussed in the first section. We can rewrite A square by B square as, yes, A by B the whole square. So we can rewrite BC square by BC square as BC by BC the whole square. So BC by BC whole square plus, yes, AB by BC whole square equals AC by BC whole square. Okay. Then can you say what about each terms? First one is simple. That is BC by BC. What is BC by BC? That is always equal to 1. Okay. So it will be write as 1 square plus AB by BC. What is AB with respect to? We are taking the angle A. So according to this angle, which side is AB? AB is adjacent side. And what about BC? BC is opposite side. So it is a ratio connecting adjacent side by opposite side. Which trigonometric ratio was that? Adjacent side by opposite side. Yes. We are already familiar about opposite side by adjacent side. That is tan. Then what will be its reciprocal? Its reciprocal is cot. So we can rewrite AB by BC as cot A. Cot A whole square equal to the next one. Can you say which trigonometric ratio was that? AC by BC the whole square. AC by BC. AC means hypotenuse of angle A and BC means opposite side of angle A. So hypotenuse by opposite side. What is that? Hypotenuse by opposite side. Yes, it is cosec A. So we can rewrite it as cosec A whole square. Okay, then we can rewrite it as 1 square, that is 1 itself. 1 plus cot A whole square. What is cot A whole square? Cot square A equal to cosec A whole square, that is cosec square A. Okay, so 1 plus cot square A is equal to cosec square A. Okay, then that is the second trigonometric identity. Okay, you can check by yourself by substituting the values as any value, any angle familiar for you. Okay, you can do it as homework. Okay, then we can move to our next trigonometric identity. First, in this all trigonometric identity, these three trigonometric identity, we are starting with Pythagoras theorem. In the first section, we divide each term by AC, and in the second section, we divide each term by BC square. Then what will be the next step, or what will you do when you move to next trigonometric identity? As we are going to divide each sides by AB square. Okay, so we can do it. Then Pythagoras theorem is always the same because there is no change in triangle, no change in side. So there is no change in Pythagoras theorem. That is BC square plus AB square equal to AC square. Okay, then next we are going to divide each terms by AB square. So how will the equation becomes? Then equation becomes BC square by AB square plus AB square by AB square equals AC square by AB square. Okay, then how will you rewrite it as? Yes, the same step. Okay, then it becomes BC by AB whole square. Then next step, Yes, AB by AB whole square equals AC square by AB square becomes AC by AB whole square. Okay, what is BC by AB? Can you say it? What is BC by AB according to this angle A? What is BC? BC is opposite side and AB is adjacent side. Okay, what is the trigonometric, which trigonometric ratio is stated with that? It is opposite side by adjacent side. Yes, that's tan. So we can replace BC by AB as tan A whole square plus AB by AB. That's always 1. 1 square equal to AC by AB. What is AC by AB? AC is hypotenuse and AB is which side of angle A? AB is adjacent side of angle A. So hypotenuse by adjacent side. Which trigonometric relation was that? Yes, it is sec theta. Okay, sec A. So here we have taken as angle A. So which was that? Sec A. So we can rewrite it as sec A whole square. Okay, so we can rewrite again it as tan square A plus 1 square is 1 is equal to sec A whole square can be rewrite as sec square A. So this is the last trigonometric identities, that is tan square A plus 1 is equal to sec square A. Okay, so we already proved 3 trigonometric identity. First one is sin square A plus cos square A is equal to 1. Next one is, yes, sec square A plus sec square A is equal to 1 plus tan square A. Then next one is, yes, cosec square A minus cot square is equal to 1. Okay, so these are the 3 trigonometric identities. Okay, then next we can move to some problems that we can use this trigonometric identity. Now we are familiar with all the trigonometric identities. Next we are going to move some problems. If we are if we have one trigonometric value of a triangle, that is, if I giving tan A is equal to 1 by root 3. Okay, tan A is equal to 1 by root 3. Okay, then can you find all other trigonometric ratios? If you know about tan A, you can directly find the next trigonometric ratio, that is the reciprocal of tan A. What is the reciprocal of tan A? Yes, that is cot A. So what is cot A? Cot A is equal to the reciprocal of tan A. Tan A is 1 by root 3. So what will be the next? That is the reciprocal of 1 by root 3. It is 1 by root 3. Okay. It's equal to 1 into root 3 by 1, that is root 3 itself. Okay. So we already got the value cot A is equal to root 3. Then next just check what we have tan A, which is the trigonometric identity involves tan A. The last trigonometric identity. What was that? Can you say? Sec square A is equal to 1 plus tan square A. Okay, so that is the next first trigonometric identity. Sec square A is equal to 1 plus tan square A. And now we have the value of tan A. What is the value of tan A? Tan A is 1 by root 3. Using this value, we can find the value of sec square A. So what is sec square A? Sec square A is equal to 1 plus tan square A. Tan square A means tan A the whole square. We have the value of tan A. Then just substitute the value of tan A, that is 1 by root 3. That is 1 by root 3 square is equal to 1 plus, what is the square of 1 by root 3? Square of 1 is 1 itself and square of root 3 is 3 itself. So the answer is 4 by 3. That is sec square A is 4 by 3. Then what will be the value of sec A? We can find it by finding the root of, yes, finding the root of 4 by root 3. Sorry, root 4 by 3. That is root 4 by root 3, which is equal to 2 by root 3. So we got the value of sec A. Using sec A, we can find the value of, yes, which trigonometric ratio? We are already familiar about sec A. What is sec A? It is the reciprocal of cos A. Very good. So using sec A, we can find the value of cos A. What is cos A? Cos A is the reciprocal of 2 by root 3. What is the reciprocal of 2 by root 3? It is root 3 by 2. That is cos A is equal to 1 by sec A, that is 1 by 2 by root 3, which is equal to root 3 by 2. So now we have tan, cot, sec, cos. Then what will be the next? We already have cos. So have you remember the trigonometric identity related to cos? Which was that? Sine square A plus cos square A is equal to 1. So using that identity, we can find the value of sine A also. So next identity is sine square A plus cos square A is equal to 1. Okay, we don't know the value of sine square A. So what is sine square A? We can find it by sine square A is equal to 1 minus cos square A. And now we have the value of cos A. What is the value of cos A? Root 3 by 2. So just substitute the value of root 3 by 2 in this equation. The equation becomes 1 minus root 3 by 2 the whole square. So what it becomes? 1 minus root 3 the whole square. What is root 3 the whole square? Root 3 square, that is 3 by 2 square. What is 2 square? Is 4. So what is the answer? 1 minus 3 by 4. That is 1 by 4 itself. We have sine square is equal to 1 by 4. So what will be sine A? Sine A is the square root of sine square A. That is square root of 1 by 4, and which is equal to square root of 1 is 1 and square root of 4 is 2. So the answer is 1 by 2. And using this sine A, we can find its reciprocal also. What is the reciprocal of sine A? Yes, it is cosec A. So you can find cosec A. What is cosec A? It is the reciprocal of sine, that is 1 by sine A. So it becomes 1 by 2 and is equal to 1 into 2 by 1. So we can cancel these two ones and the answer is 2. So we only have one trigonometric identity ratio. Using that value, we can find all the trigonometric ratios of the triangle. Okay, clear? So it will be the first use of this trigonometric identity. Okay, thank you.